Good morning and happy Thursday. So I'm going to spend today and tomorrow finishing up graphing, solving algebraically systems. And there are other systems out there. So we've done lines algebraically, we've done parabolas with lines. We also had a touch of circles with those word problems, right? Because when the x and the y squared are both positive, a circle. But this actually isn't a circle. This wraps up our systems unit. This actually, if you graph it, is a graph of a hyperbola. So the circle is no longer connected. Don't know if you have ever experienced that, but that's typically taught in a pre-calculus class, but it's not in IB math. So if one of the variables is negative, you're going to have, instead of a circle, it's actually going to open up two different directions, opposite sides. So for today, I'm going to take a look at example number 1. And I know the questions are multiple choices. I'm going to show you algebraically how you can find the points of intersection. So if we take a look at example number 1, y squared minus x squared plus 32 equals 0, and the line 3y minus x, it'd be easier to change the line into slope-intercept form. So I just brought the x on over, and I squared both sides. And I didn't even really put in slope-intercept form. I kept a 3 there. I didn't want to deal with a fraction, you see. So by squaring both sides, I get 9y squared. Remember, when you square the 3, 9, square the y squared, 2 times 1 is 2. We're going to substitute that where we see x squared. Now, I'm kind of glad to do this now because some of the mistakes I saw on the quiz is that when people were squaring both sides and went back to substitute, they forgot that there was another term there. So y squared is still part of the package. Don't leave it behind. Then you have minus, replace the x squared, the 9y squared plus 32. And what you'll have here is an equation, quadratic, that's all in terms of y. No problem. Combining your like terms, you'll have here negative 8y squared plus 32 equals 0. Now you have two alternatives. Some of you might see, hey, I have a GCF of negative 8. Factor out the negative 8, and then you're left with a really nice difference of two perfect squares. Using the square root method, you get two answers for y. Now keep in mind, those are the y values, so negative 2 for one and 2 for the other. And then once you know the y is 2, you could go back, eeny, meeny, miny, mo, this is easier. In fact, even this is easier. So if you plug in negative 2 for y here, 3 times negative 2 is negative 6. And if you plug in positive 2 here, 3 times 2 gives you positive 6. Now, some of you may have not seen this. So is there another plan? Yes. You could have brought the 8y over, the negative, 8y squared over to the other side. So it cancels the negative and divide both sides by 8 and use the square root method. You would have gotten the same exact answer that way. So I'll send you a copy of this example number 1. But I do have another example here worked out for you. There is a fraction. We might run into the risk of some heavy-duty factoring, so you might want to resort to the quadratic formula, which I did with number 2. So number 2, again, x squared minus 4y squared equals 16. That's a hyperbola, it's called. And we have a line. So what I decided to do, like the quiz, I decided to take the line and square both sides. I can't complain about this. You guys did a wonderful job squaring, combining like terms. But remember, want to go back and plug that in where we see y squared. Still have an x squared, you still have a minus, but then you have a 4. We need to distribute the 4. So x squared minus 4x squared, negative times negative makes that positive 32x, negative times negative, and I brought the 16 over. And when I combined like terms, I was really hoping I made a mistake there, but I double-checked I didn't. And then I changed all the signs in attempts of factoring. I thought, I don't think I want to multiply 3 with 80 at 240 MFRT. So I scrapped it. I went right to the quadratic formula. And, it just worked out nicely with the signs that the discriminant, after you take the b squared minus 4ac, I got 64, which is a decent perfect square to work with. The square of 64 is 8. So one of the answers for x was 32 plus 8 divided by 6. Now that's 40 over 6, which reduces to 20/3. It's kind of lousy, but with scientific or graphing calculator, you can plug that in for x here and get the y value, which is 8/3. I know, not the greatest looking, but it is a solution. The other answer, 32 minus 8 is 24, and 24 divided by 6 is 4. And that was really, that kind of makes up for the other challenging problem. 40 was the other point. So again, these are examples of conics, they call them. So it's not two lines, not a parabola line. It could be a circle, the line, or it could be like in this case here we have a hyperbola. If there was a plus sign there, we call that an ellipse. So it's more like the shape of an egg. You know how the egg is not a round circle, it's more oblong, oval looking. Those are called ellipses. So today and tomorrow we'll just do some more practice problems to wrap up systems here. If you have any questions, just let me know. But for homework, try numbers 3 and 4. If you didn't get the quiz to me yet, please, when you get around to it, please do that soon. Thanks, and have a great day.